Good morning, students. I hope you all are well and doing linear algebra comfortably. Till date, we have defined several basic things and the definition of vector space and some examples based on this. Today, we'll consider one more example that is actually a question. If you look at this, let V equals to R square and define addition and scalar multiplication as follows. Yesterday I explained what is the meaning of R square. V is R square, means it is R cross R, means it is x comma y such that x y belongs to R. Set of ordered pairs. This is a point in 2D, two-dimensional. It is in xy plane. So, which type of set is given? This set contains points in 2D, or this is set of ordered pairs. So, whenever we want to prove the given set is a vector space, first we decide, first we think, first we identify which type of set is given and the nature of elements. So here the nature of elements we found, V equals to R square. Okay. Then V is along with two operations. One is addition and other is scalar multiplication. Remember, if it is standard addition operation, I am saying standard addition operation with respect to pairs, then first component is added to first, second to second, third to third, and so on. Similarly, standard scalar multiplication, it is just like to multiply a number by a matrix. We multiply all the elements of the matrix by that particular number. So this is standard addition operation and standard scalar multiplication. So here we see V equals to R square and define addition and scalar multiplication operations as follows. You consider two members from V, that means alpha and beta. What is the nature of alpha? In the form of ordered pair. Beta, again it is in the form of ordered pair. So alpha is this, beta is this. Alpha plus beta, first is added to first, second is added to second. So this is the standard one. Standard addition, or we can say regular addition operation. This we have done yesterday, but remember here the plus sign is between two vectors, means the members of V, and generally we use this symbol, you know that. X1 and X2, Y1 and Y2, these are real numbers. So this is ordinary addition, this is also ordinary addition, but this is not the ordinary addition. Here the operation is, you know that it is from V cross V to V, internal composition. And if K is any real number, then define this one. This operation is not the standard scalar multiplication. Yesterday, if you remember, any constant, suppose I write K and this is x comma y, then we write this is kx ky. This is regular, or I can say standard. You have to remember scalar multiplication. Okay, so be careful what is given. This operation is regular or standard addition. This type of operation is regular or standard scalar multiplication. This we have done in the same example, but with the help of ordered pairs. Similarly, it is done with the help of matrix and a number. Similarly, this can be done with the help of number and a vector quantity that we have defined in vector algebra. So, here v equals to r square. These two operations are defined. It must be clear that what is the rule of that particular operation. So, it is the regular addition or the standard addition. But the second operation is not regular. Here k times alpha means, here you remember here is k dot with circle, that means it is scalar multiplication, and this is defined, as you know that this is a real number, so it is r cross v to v. Whenever the field is not given, always remember the field is a set of real numbers. If other than this, then it will be mentioned in the question. Okay, so here let v equals to r square and define addition and scalar multiplication as follows. This is the addition operation and this is the scalar multiplication, but this is not the standard one. If I write kx1 comma kx2 ky1 just like this one, then it will be as usual as we did yesterday, but this is different. Okay, here the second element is 0. Determine whether V is a vector space. I will not prove this operation as an abelian because this we did yesterday. It is standard one, standard addition. So we people know that this operation is associative, this operation is commutative, this operation has inverse, this operation has identity element, this is also closed. So V is an abelian group with respect to this. So first 5 properties be satisfied. Okay, we will come to the next one. Also, such that all alpha plus beta okay, you can see here alpha is x1 y1 and beta x2 y2 and beta. Operation is given, so it is x1 plus x2 y1 plus y2. This is in R square. That means this is in V. Therefore, this is closed in V. Similarly, you can prove associative, commutative, such that there exists such that the source, that means identity, exists. Identity elements or zero elements or zero vector exists. Okay. Also, if then why? Yesterday it was explained. This is the ordered pair because this is the member of R square and V is equal to R square. What is our set of real numbers? So these are real numbers and R is the field. So every point in 2D, so we can write this one. So if this, then this one. Now, therefore, for every x comma y, there exists that means additive inverse exists. So all 5 properties be satisfied here. Therefore, V with respect to this is an abelian group. Okay, this is an abelian group. This is the standard one. Yesterday it was done. Again, it is repeated. Now we come to the next one. Scalar. Okay. This is such that element of this k is scalar. Here I write alpha. According to this is given to us. So this is k x1 comma y1, because alpha belongs to V and this is R square, order pair. So image of this one is, according to this is given as k times x1 comma 0. This is in R square, therefore this is in V, therefore this is closed in V. Closure property holds. Number 2. Let AB belongs to R. Remember, filled. These are the steps. Suppose alpha is x1 comma y1 belongs to V. Therefore, remember this is ordinary plus, but here the sign is, this is vector, this is scalar. Scalar vectors. So this is scalar multiplication. That means the symbol is B plus B. Alpha means x on y. Write it here. Okay? And here this is the definition. K times x1 means A plus B times x1, comma, second component is 0 by the definition. Here it is 0. Also, remember the sign here, scalar multiplication. The sign is scalar multiplication and this is vector addition. So it is A alpha, and by definition A alpha, what will be this one? It is A x1 comma 0, because alpha is x1 comma y1. This is B x1 comma 0. How to add? It is given first to first. So it is A x1 plus B x1. 0 plus 0. This is A plus B times x1. This is also belongs to R square because it is pair. This also belongs to R square and this is the pair. Let's see. So here left hand side is equal to the right hand side for all this one. Therefore, for all A comma B belongs to R and for all alpha belongs to V, we have A plus B alpha equals to A alpha plus B alpha. But you must remember here this is the symbol, here this one, here this, and here this one. Be careful. Similarly, you can prove the third property. Similarly, third, okay, just like A alpha plus A beta. And fourth, A B alpha means A times B alpha. Associatively, this we have done. Here the symbol is dot, ordinary multiplication. Simple. Scalar multiplication, ordinary one. And here, this is this. It is this. It is this. Okay. Because finally this will be a vector quantity. Scalar. Now fifth one. Since R is filled, therefore 1 is the unit element. Let alpha x1 y1, this belongs to R, that is B. Okay, so now one alpha means it is one alpha. That means it is one x1 comma y. According to definition, it is 1 into x1 0 by definition. Given. This is not alpha. Because alpha is this. So, first 5 properties, that means for abelian group with respect to addition. Then the next 5 properties, combination of plus means addition and scalar multiplication. 9 properties are satisfied here. 9. The 10th one, the last one, is failed. 1 into alpha must be alpha, and here this is not alpha. Yes, if this member is 0, then it will be. Otherwise, it is not. So here it is y1 is not equals to 0. Suppose I say let alpha is 2, 1, 3. And then alpha equals 1 into 2 by given rule. This rule is given. Remember, this is not the ordinary scalar multiplication. Second member is 0 according to the given rule. That's why it is 0. And this is 2 comma 0. And which is not equal to alpha. You can see. Nine properties are satisfied, but the 10th one is failed here. Therefore, V equals to R square along the given binary composition is not a vector space. Along with the given binary composition is not a vector space. So sometimes we feel that first is satisfied, second, third, fourth, fifth, sixth, seventh, eighth, ninth, and we say yes, it may be 10th one. But this is the example in which you will find 9 properties are satisfied, but the last one, that is the unit element with the vector, this is not satisfied. So this is not a vector space. This is a very good example. And if this type of operation is given, addition is as usual, but scalar multiplication is different from the ordinary one, then it is better to check the last one. That means for identity with respect to the scalar element. So if you find at least one property, at least one that is not fulfilled according to that, then the given set is not a vector space. Thank you. If you have any difficulty, you can ask. So you write your comments in the comment box. Thank you very much.